Hello everyone, welcome. This is Organic 1 Lab. This will count as the acid-base extraction experiment video. So here we see our balance, and we have an unknown that is being weighed out. Per our instructions, in the first step we need to weigh out approximately 1.5 grams. Alright, so the unknown of choice here is unknown A, and you can see we've gotten about 1.5001 grams. Alright, now we're adding that unknown to an Erlenmeyer flask where we're going to dissolve it in an organic solvent, specifically dichloromethane. Alright, we need about 40 milliliters of this, so you're going to see this graduated cylinder here holds a maximum volume of 10 milliliters, so we're going to have to measure out 10 milliliters 4 times. All right, there's our third addition, and then here's going to be our fourth addition of 10 milliliters. Alright, so shaken / stirred. Ooh. Alright, so dissolved it, got a homogeneous mixture. Alright, so just using the pipette to do a little extra mixing. Alright, now we're going to take that solution, our unknown A solution in DCM. We're adding it to our separatory funnel. Alright, and so adding to that, we're now going to add 5% sodium hydroxide solution. We're going to add 15 milliliters. Alright, that should be 10. So now we're going to add the 5. Alright, and so now we shake it. Oh, there you go. We shake it, shake it, shake it, shake it, shake it, shake it, shake it. Whoa, shake it, shake it, shake it. Alright, trying to get everything good and mixed up. So, in essence, if we have an acid in our unknown, it should react with the sodium hydroxide, and when it does, it will turn into an ion that will be highly soluble in the aqueous layer. And so big picture here is you have a solution of sodium hydroxide, and then you have a DCM layer, so your aqueous layer and your organic layer. So based off the density, you need to be able to determine which layer is which. Is the top layer your aqueous layer, or is the bottom layer your aqueous layer? All right. All right. So anyway, so we let it settle. Make sure that everything is well separated. We have two well-defined layers, and so now going to remove the bottom layer, adding it to a beaker. All right. There we go. So we still have a little bit left. You can barely tell the difference in the two layers. Alright, so there's our bottom layer, which based off of density, I hope you know, is your dichloromethane layer, your organic layer. Alright, alright, and then separated out the basic layer, put our organic layer back in that separatory funnel, and so now we're going to perform the sodium hydroxide extraction. Here we're doing it a second time, so shake, 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 shake. Oh, you didn't know I could shake it like that, could you? Woo! I went hyperspeed on that one. Alright, so then going to allow it to settle, and then go ahead and remove the bottom organic layer again. Okay. Alright, so in essence, remember we added a base, so that organic layer should possess our basic compounds or our neutral compounds if they're present. And so the basic layer, the aqueous layer that we took off, that would have our acids in it if we had an acid. Okay, so added the organic layer back. We have a that sodium hydroxide extract layer chilling in an ice bath per our instructions. Alright, now to the organic layer. Per the instructions, we are going to now add 5% HCl. Alright, and this will react with any base that may be present. in our organic layer, and if it does react, it'll turn that base into an ionic compound, making it much more soluble in that aqueous layer, in the HCl layer, which is aqueous. All right, mixed it. All right, turned on the Millennium Falcon's hyperdrive, did a super mix. All right. Oh, and one note here, you'll notice that if you ever forget to take the cap off the top of the separatory funnel, you will notice that it starts to bubble, right? Because in essence, you have a vacuum, and it doesn't want to allow the solution to drip out of the bottom of the stopcock when you turn the stopcock. So I'm doing this extract 3 times. Here's our second edition of HCl. The third edition I do not believe is going to be shown. All right, allowing it to settle so that we can remove, there you go, remove that top. All right, and there's our aqueous layer. All right, so we have an acid extract in the middle, our basic extract is chilling, and now our neutral, which was the organic. So remember now, we do have 3 extracts here, but now only 2 of them will contain something. One of them should have nothing in it. And then what you see also in that neutral extract beaker, we have added a drying agent, which is going to be sodium sulfate, right? And that's going to pretty much absorb any water or aqueous anything that got left behind in the organic layer. Okay, and so really you want to add, you're supposed to be able to see it's a little clumpy. You want to add enough sodium sulfate to where you still have a whole lot of fine looking powder. All right, so going to pH, so here we have pH strip showing you the legend from pH 1 to 12 or 14, so that you can kind of see what's happening here. So now to the sodium hydroxide extract, the one that's been in the ice bath. All right, so that basic extract, now adding 6 molar HCl, and we want to add that until our pH tests acidic. All right, and that pretty much allows us to take that acid that was turned into an ion. Since you're changing the pH again back to acidic, it will neutralize it and you'll get a solid. And so that nice pink, fuchsia, magenta, not very great with color names, but anyway, you can tell how it's sort of a reddish pink color. It did pH test acidic. And then the fact that we see all of that white powder in there tells us that we did have a solid, something did get extracted into it. And so all that white powder should be our acid that was removed from unknown A. And so now with the acid extract, we are going to add base, specifically 6 molar sodium hydroxide. And if you notice, you see how each addition of sodium hydroxide, we see a white solid, this white kind of nastiness go about. All right, pH tested, it was still acidic. So then added some more sodium hydroxide. Now you see all that white cloudy stuff. So yet again, oh, pH tested it. That indigo color tells us that yes, it is a basic pH. All right, so now that we have both of our solids, going to weigh out our watch glass and filter paper so that we can do a vacuum filtration. All right, so first up, we're going to look at the mass obtained for the acid extract blank. All right, so 56.5613 grams. Then the mass of our base extract blank was 111.7911 grams. All right, so performing our vacuum filtration, you can see what you're going to see here, right? Now, we now have a clear solution at the bottom. All right, so the solid has been properly separated. All right, and then we're washing the solid with some of that cold water. All right, then we're going to set it to dry on the hot plate. All right, so drying, then we're going to do a quick jump to after a while to where it's finished drying. But right now we're testing the filtrate. It came up with an acidic pH, so that means it's going to go in the acidic aqueous waste. All right, so now it's dry after a while on the hot plate. All right, now measuring out our dried solids on the watch glass and the filter paper. Our basic extract has a mass of 112.2790 grams. All right, our acid extract has a mass of 57.3895 grams. Now remember these masses, you do have to subtract those blank masses from them that we saw earlier. All right, so now going to test the melting point of each one of our extracts. All right, and so to be honest, when you're setting up this Digimelt to do everything, you actually do want your temperature range to cover as much as possible. So really, you could just focus on those acids and bases that are in that table of possible unknowns. All right, and what you saw is using the capillary tube, trying to get some of those solids in the capillary tube. All right, and so you can see tapping the the capillary tube to try and get some of that solid at the bottom. All right, and so we have each one of our extracts, 2 different capillary tubes. And so now setting up this Digimelt, the melting range set up for it is going to range from approximately 40 to one of our highest melting points is approximately 205. So going to go from about 30 to 250. All right, so we can see our acid extract has already started to melt around 78. Started at 78 and finished around 79 degrees C. All right, and so you can kind of see it finishing up. All right, so now moving on to the next one. You can see our temperature reading is already about 103. All right, and so pay attention to the far right tube, not the middle tube. All right, so the far right tube, you can see it's starting to kind of wiggle a little bit, and so the base extract melts from 115 to 119 degrees C. All right. Now, also you need to remember, right, when I said it was the base extract, that means it was extracted with a base. So we're actually talking about our acid. So when I talked about our acid extract, that compound was extracted with an acid. So make sure you recognize that, yeah, the acid extract is actually a base solid. All right. All right, so from here you should be prepared to start writing up your lab report. Thank you.